Welcome to Eplan Spotlight. Today our topic is Eplan Electric P8 and the options to automate your design process. My name is Thomas Michels and I'm here with my dear friend Sean Mulherin. Hi Sean.
Hi Thomas, how you doing?
Fine. Nice to have you here in the studio.
It's always a pleasure to be here.
So maybe as introduction, let's have a look at that wording automation. So when we talk about automation in the electrical or in the Eplan Electric P8 context, we are focusing on all the options to automate all the steps or main steps in the design process for schematics. So to get faster and maybe to get rid of these manual tasks. So not to mix it up with automation when we have a look at a machine or a plant where we talk about PLC components, etc. So we are looking here more at the design process. And then maybe a good idea is to start having a look at Eplan as a system. And Sean, may I ask you to give some insights into, let's call it the philosophy of the system that gives these opportunities to automate design processes in Eplan?
Absolutely. So Eplan really is more than ECAD. And Eplan right out of the box already offers a lot of functionality to help you automate your designs, automate your processes in the design of schematics. And let's go through some of those functions and features that really enhance Eplan and make it different to the traditional ECAD systems that you are probably used to. So first, let's talk about templates. Templates is the foundation of a design. It defines the environment and defines everything you need to create a design properly and accurately according to the company standards. And of course, if you've logged on to eplan.com, then you can also take advantage of all of the default templates that we publish there, and that can help you jumpstart your engineering. So templates are the point number one to start efficiently in your design process. Next, we move on to symbol libraries. What's an electrical schematics without any symbols, right? And where do those symbols come from? Eplan provides you the libraries you need to design your schematics efficiently and quickly. Whether it's IEC symbols, NFPA symbols, or if you work in the fluid environment, you've got ISO 1219 symbols. So Eplan provides those standardized symbol libraries straight out of the box for all of the users right from the get-go. And then finally, a topic which is actually always underestimated because it's called auto-connecting. What's fun about auto-connecting? Well, a lot. In fact, auto-connecting is probably one of the most underrated features in the tool because it really helps you to quickly piece all of your circuits together in very, very quick time. And that we'll take a look now in the system. So here we've got an empty page. So first off, talking about templates, when you create a new project, the system's asking you which template do you want to use. And it can be a template from a customer, it can be an IEC template, an NFPA template, and those already provide you all of the borders, the naming conventions, and everything associated with your particular project. So we created a project here. I've already a couple of pages with some power distribution, and now let's take a look at the symbol libraries. From a symbols perspective, you can quickly access here in the Insert Center an IEC library organized according to specific categories like protection devices, motor overload switches, and you can simply take your symbols, drag and drop them in the system, and quickly position them so you can efficiently design your system. But now let's take a look at the auto connecting line and how that works. I created some tags so I can quickly access my symbols. You can also tag your macros as well as tag your devices to make it quickly accessible. Then let's go to my motor starter system. I'm going to go to my IEC layout and I'm going to start off with a three-phase system. So first off, X and Y. It seems also pretty easy or pretty simple, but X and Y gives you the exact position that you position the last component. What that does, it helps you to be accurate over the drawings and not have lines up here, lines down there, lines up here when you flick through the pages. It looks like an animation drawing, right?
Yeah, can happen.
So now I've got my power lines, I'm going to place a motor. So let's do a motor starter. So just dropping the motor in here, and of course the system labels the motor automatically, and here we have it. Now I'd like to connect this motor to my power system. So I can just simply move those T connections up there. And as you can see, auto connecting line is already in place and connects the power to my motor directly. Now I need a ground component for this particular motor, so I'm just going to drop it in. And now I'm going to place a terminal strip to go from the field all the way to the panel. So here you have it. And now I'm going to place a cable. So under insert, I can insert a cable quickly and easily and just place it over my power lines. So this is just kind of basic functionality in ePlan that you can see really helps you already put a system together quickly. Now let's quickly protect this device. So let's control it first with a contactor, and then let's place a protection device. So now I'm going to go to my library, my symbols, IEC, electrical engineering, protection, motor overload switch, and simply drag that and drop it in there. And there you have it. The system is created and laid out quickly and easily.
Okay, let's go back to the overview and maybe summarize it a little bit. So what maybe is important right from scratch is the availability of these templates, of these projects, so that you could say, okay, it's the IEC standard, NFPA, everything is supported. And as we all know, that ePlan has a lot of different settings you can do. So all these settings are prepared to support the standard, so you don't have really to care. And I think that is extremely important also for people that just start with ePlan to directly get the right working environment. Yeah. So you mentioned eplan.com, so it's really important to have a look there for the templates. Symbols, you said, it's not only the graphic, it is also the data and the, let's call it the type of the component behind. And when we talk about automation and support, when ePlan knows there's a motor, the motor directly gets the right designation when you put it to the schematic, because the software knows it is a motor, it's a drive, or it's a circuit breaker or whatever. And then auto-connecting, you said, yeah, just faster, faster design.
The most underrated functionality in ePlan, I think. I like it a lot.
And I'm sure, Sean, you have more.
Yes. So now the next step is let's take a look at taking the core concepts and applying them to become even more efficient. So let's talk about macros. What is a macro in ePlan? It's a partial circuit, it's a partial template, or it's a template circuit, as you could say. So what it is, it's a collection of symbols and parts and devices all combined together. So instead of having to manually place each individual one, as we did earlier on, now you can store that circuit and reuse it quickly and efficiently, making the design process even faster. And then if we take this particular circuit and then we can enhance it with variants, because you might have a forward motor, a forward and reverse motor, a slow start, a soft start. Various different combinations of symbols provide you different functionalities for the motor starters. And these can be stored in variants. And how many variants do you think we have?
A lot.
We have 26 variants, A all the way to Z in terms of variants, just like our engineering process, right? A to Z in terms of variants. So one macro, you can store 26 different variations of that particular circuit. Now that we have the base, we have the variations, and then what's missing is the placeholder, the data behind it. And using the placeholder technology helps you to capture all of the engineering data and apply that data to those circuits quickly and efficiently during the design process. So let's take a look at the system and see how that works. So here we just finished our symbol placement, so I'm going to remove that particular aspect, and I'm going to start with a three-phase again so that we can quickly lay out our circuit. So I'm positioning my circuit, L1, L2, L3. Now, instead of selecting symbols, I'm going to select a motor module. So if I drag this motor module, as you can see, I have a complete circuit that's available to the user. And now using the tab key, you can see I can access different variants. So these are the variants of that particular circuit. So simply using the tab key, I can access all 26 of the variants. I don't have to create 26, but if I do, I just use the tab key to access them. And then once I've selected the tab key, I just simply place it, and now we're talking about the value sets. In this case, the circuit, if I have a 2 horsepower motor or a 10 horsepower motor or a 100 horsepower motor, that changes the overload size, it changes the wire size, it changes the cable size, and all of this information can be captured inside of the value set. So here let's choose a 3 kilowatt motor. And based on that 3 kilowatt motor, you can see that the fuse is a 25 amp fuse and is a 3 kilowatt contactor as well. So now let's go and change that particular motor size. So now I could assign a different size. For example, let's change it from 3 to 15. And by simply switching it from 3 to 15, now you can see that the fuse size has changed, the protection size has changed, the wire size has changed, all of that has changed according to that selection. So it's a very quick and easy way to not only capture your standards, make sure that you have a library full of those circuit diagrams, and also capture the knowledge of your engineers to be able to store those values, right? Because based on their experience and also electrical calculations, they can figure out the size of the motors and the size of all the components that they use. So there you have it. Inside of ePlan, a quickly and easily way to lay down your controls design, quickly capture your engineering data, and also the different variants you need.
Okay, so maybe let's have a look back to the slide we just started from. There you see, let's call it the way, yeah, where we make the first steps into reusing parts of schematics, yeah, and then of course enrich them with more and more engineering support. And just to point it out, this is all standard functionality of Eplan Electric P8. So, for example, if you are already a user, just have a look at these possibilities there and then make your first steps in starting a first template, then maybe collect more and more templates to build up a library. And the nice thing is that it's not only a function in the software, it's also a work or a change in the work mode. Yeah, you change your method when you go more and more template oriented and work more and more from a library. It of course on the one hand speeds up your engineering, but on the other hand, if you take care for the quality of the library, you are always sure that all the projects you design from that point on have that level of quality. Yeah, you can add more and more data, and the system gets more and more professional. You have more and more potential maybe to create reports. And what we saw, by just changing these value sets, you can extremely fast react on changes that are coming maybe from the mechanical design. Yeah, if they change the motor size, for you it's a click. Yeah, and maybe you can cheat the guys a little bit in mechanical design. Yeah, to just I have to change my schematics, but it's done by a click.
And you don't have to remember it; it's stored inside of the library, right?
Absolutely, yeah. And I think that especially maybe the more experienced engineers and the more experienced users of ePlan can be the guys who in future create these libraries, and then new colleagues are able to onboard much faster into the system.
Absolutely.
Great. I think there's more.
Yes, yes. Another aspect is once the project is created, the user needs to be able to translate that project. So translation, specifically here on the European markets, you have multiple different countries, multiple different languages. So you build a machine in Germany that has to be delivered in Spain or in Portugal, and of course you have to deliver it in the local language, and plus maybe in English or in German, depending on the engineers that are working on the machine. So using ePlan, we've got a completely translatable database that helps the user switch languages or display additional languages based on the requirements quickly and easily throughout the project. Then we're talking about reports. The most common report, or probably the most famous one, is the bill of materials. So the bill of materials is a list of all the parts you need to order and to build the control systems. This can be generated in ePlan with a click of a button. Same thing for your wire list. Same thing for your terminal diagrams, your cable list. We have over 50 different types of reports that can be quickly and easily generated automatically using ePlan. And finally, PLC data exchange. In the schematics, you capture all of your input, your I/O information, inputs, outputs, you capture your PLC systems, but now the programmers, they don't want to manually take it off, right? They want to be able to automatically take all the data you created in ePlan and then leverage that to start writing their code. So ePlan provides you with a direct PLC exchange to many standardized PLC manufacturers, whether it's Siemens, whether it's Rockwell, whether it's Beckhoff, B&R, Phoenix Contact, Mitsubishi Electric, Omron. We got many different PLC providers that have a direct interface to ePlan, and also maybe using the Automation ML interface if available. So let's take a look at ePlan and see how that works. First, let's take a look at the translation aspect. So when I hit a text and I select a specific text, for example, power, you can see that I already have an autocomplete that's there. And if I can right-click and go to my multilingual input, you can also see that I've got multiple different languages that are available for me to manage. But I don't want to manually type it in, so of course we got a dictionary, and the dictionary can pick and choose that text that you have. So for example, here I'm just going to type in power, and then it's going to select all the parts or the names that have power, and then I can automatically translate it and drop it in here. You can also highlight the entire project and say I would like to translate all of my texts. In this case, what you would do is in the Tools menu, you would go to Translate, hit this button, and the whole entire project is automatically translated at the click of a button. So translation functionality really makes it easy and fast for the user to translate his project. Next, what you can do is generate reports. So to generate reports, you simply highlight your project, you go to the menu Generate, and here we've got templates already stored with the template that you chose. So you start with a template, and inside of that template you already have some other reports that are pre-configured. So now I'd like to generate, for example, a summarized parts list. I like to generate a cable diagram, a cable overview, a connection list, device list, and all I do is click on this button and the system goes through and generates all of those reports automatically for the user. So here you have it. You can quickly look at your reports, such as here a connection list or a summarized parts list, but automated generated reports. And finally, data exchange inside of the platform. Well, if you have a PLC and you need to export the data, then you can simply go to File. Here you've got Export. You can export your PLC data, and here you can specify which hardware vendor you want to use. Here we've got a list of choices you can pick from, so you can see it's quite a few, huh? And then also you can pick the Automation ML version you want, and that file can then be exchanged with PLC manufacturers. So there you have it. Additional functionality straight out of the box using ePlan to really help you become more and more efficient.
A big bunch of topics. So let's have a look at the overview again and yeah, summarize and maybe add some aspects. So we saw that first of all, translation. So I can say it because I'm an electrical engineer and I'm not really interested in translating something. So I can, as I learned from you, Sean, I can really use this library in the back. So you have all the translations there. You even get support so that maybe it's not a wide variety of phrases or words that are used. So you're standardized in your wording. And that helps again to create a high quality in schematics or make it easy to read the schematics and understand, because people are standardized on the wording inside the schematic.
Can I tell you a secret too?
Of course.
I did a project in a language that I didn't know, and I did that how? Because I took the English language, I exported it, I translated it using a translator in the cloud, and I imported it back in ePlan, and there it was, translated in an instant. Too easy. Yeah. It's too easy.
Cool. Sounds great. And then the wide range of reports, the possibilities that are there. There it's important to understand that it's some kind of understanding, or to understand the schematic as the source for the data. So everything regarding data, descriptions of components, parts information, wiring data, all these topics are put, or this data is put into the schematics, and from there you can derive it very flexible in a lot of different kinds of reports, so that you always forward the data in a prepared way for the receiver of the data. Let's call it like this. Yeah. So, for example, a bill of material, you forward it to the buyer, for example, in the commercial department of your company, and this guy is not interested in schematics. He wants to just have a list. Okay, this is, or these are the parts I have to order, and that's it. Yeah. So just to change the data so that it fits to the receiver. So
absolutely.
To say, yeah. And then finally, the PLC data exchange is a big collaboration topic. So in former times, we all know that maybe the PLC programmer is the poor guy during the startup phase of the machine, is sitting in front of the cabinet and doing some last modifications in the programming. And if you align with him upfront and everybody knows about the addressing or the function text, the quality is much higher, and you can maybe spend, or you can save days or at minimum hours in this startup phase.
Absolutely.
Cool. Okay. I think there's the next step, right?
Yes.
Okay.
So this is ePlan out of the box. So you already gain a lot of efficiency just by using ePlan out of the box. Next, let's talk about automation. And as Thomas mentioned at the beginning, it's not automating the machines, it's automating the design of those machines. And for that, we have a tool or solution called eBuild. eBuild is a cloud-based configurator that allows you, with entering certain parameters, automatically generating a lot of the documentation for controls design. And important, you don't have to generate 100%. You don't even have to generate 80%, but already generating 10%, 20% of your schematics can help you a long way at becoming even more efficient in your engineering process. So let's start with the schematics. So we just took a look at the software and we saw that I can create a motor starter. Well, the motor starter comes in various different sizes. I've got here a 1 horsepower motor. Then we've got here another one with, or a 2 kilowatt motor, sorry. We got a 4 kilowatt motor. I've got a circuit with a 6 and I've got a circuit with a 10 kilowatt motor. What's the difference between those circuits? The data. From a circuit perspective, they all look the same, except that the data changes. So instead of having a user trying to handle those changes manually or even using value set, why not automate that process, capture the data, and have a system generate that data for us automatically? So what we have is we have a configurator, and that configurator allows you to capture the information, capture the data, assign the data to specific standardized libraries, and then generate it. Here we've got 4 motor circuits, and now I can go ahead and configure each one of these motor circuits to be able to output exactly the result that I need.
Okay, so this in combination, I think the templates and the different parameters, and because the schematic is more a functional view, so it stays somehow the same, but the parameters change. And I think, Sean, it would be great, maybe in the next slide, I know that you prepared an overview how this all works, and I think it's a good way to understand the principle, how this works, and what are the different, let's call it, components of this workflow or this function. Yeah.
So here we've got on one side we've got eBuild, and that is the tool that captures the parameters and that allows you to combine the information. And then on the other side we've got our library, and our library are all of our standardized circuits, and also you can capture the value set. So a combination of eBuild with the rules and the library together help you to generate all of your entire schematic design. And as you can see here, now instead of manually creating those 4 motors, I generated those 4 motors automatically using eBuild. So really combining eBuild with the library allows you to capture, 1, your intellectual property from work, and also 2 is repeat the designs over and over, change some parameters, and generate the designs in much, much quicker time than you would need.
Clear structure, and I think it makes clear that we have these 2 components, the libraries, and that we have the templates, and that they are combined together. And everybody is now really looking forward to see it live in the system, right?
Absolutely. So let's jump into the system and let's see what this looks like in ePlan. So here I've got my project from previous, and all we're going to do is we're going to add to it, and then we're going to start generating some additional pages. For that, we're simply going to go to eBuild. eBuild is free. There is a free version, of course, and there's also a paid version, but the free version gives you access to standardized library. So if you haven't signed up today, sign up to eplan.com and access eBuild today to be able to generate already certain designs automatically. One of these designs is a sample that we provide out of ePlan. It's called the sample macros. Then I'm going to generate this into an existing project. And here we've got a various different collection of configurators. So you can put multiple configurators or just one, depending on what you prefer. Here we'll start with a motor starter circuit. So here I'm going to select my drive design configurator, and then I'm going to select here the parameters. So you can see here, select the drive control. We have 3 options. I can either have it direct online, I can have it a reverse motor, or with a frequency converter, with a drive. So let's just start direct, simple. I've got 2 different size motors for this one, 1/2 horsepower or 1/2 kilowatt and 1.5. Then how do I want to connect the motor to my control cabinet? Using connectors or using terminals. And then I'm going to put a page description. So this is, for example, for my pump application number 1. So I'm just simply pump number 1. And the higher level function I'm just going to leave as is, and the function text is just going to be a feed, for example. Now I'm ready to generate, and by simply clicking on the button generate, now I have generated one page of motor design. And you can see here's my MA100, and as soon as I open that page, I have access to the result. If I now go to eBuild free and I change a parameter, for example, it's not direct, it's going to be direct reverse, I can regenerate that page, and ePlan is just briefly going to close the graphical editor and show you the result as a new lead generated schematics. So interactively, you can also see the result before you actually confirm the result and continue on with your drawing. And now let's change, for example, the 1.5. I'm going to change it with a frequency converter. I'm going to put some pins. I'm going to put it pump number 2. I'm going to change the location, so I'm creating a new page. And now if I generate it, then we have our result. And here's, for example, M101, which created a new page. And now you can see the result with the frequency converter. So again, a quick and easily way to capture configurations, capture parameters, combine those with standardized circuits, and easily automatically generate those drawings inside of your project.
So this approach with these libraries and the parameters and the very easy to understand and to use interface, I think is a perfect way also to maybe take the experienced engineers, build this environment, and then just use it in daily work by themselves, yeah, to be just faster. Mm-hmm. Or maybe new colleagues also have the possibility to use all this functionality already without the need to understand what is going on in the back. So it's very easy, and the onboarding is fast. Yeah?
Yep.
Yeah.
Another aspect is consistency.
Mm-hmm.
Using configurators, you'll always have a similar result in terms of design, placement of drawings. So from a graphical perspective, you don't have to worry about it. Mm-hmm. But from a data perspective, the configurator is going to make sure that everything is set up correctly.
And did I understand it right that it's scalable, so that you showed, okay, you can create one page, or you can create 10 pages, 20 pages, up to 80% or whatever of your project, and then it's also possible to grow with that method, that you say, okay, I start with maybe motors or actuators, and then I add sensors and later PLC?
Absolutely. We've got customers today, all they do is generate drawings for their drive panels, for example, and then they want to expand and now focus on the PLC panels. So you don't have to do everything at once. Mm-hmm. All you have to do is you can start small and you can grow with the system and automate your engineering as you go. Okay.
So is it time to summarize, or is there something more?
I think we're good.
Okay, perfect. So let's maybe jump back to the beginning. So we learned that in the standard environment of ePlan, there's already a full power of features that is driving this automated work steps. Yeah, we saw that there are templates, all the symbol libraries are there, auto-connecting, we can translate, we can exchange data. And then already the first steps in these templates, in these small parts of schematics, all that is standard. But with each step, I think you lay your basis to really go further and further into then this area of automated engineering. Mm-hmm. Yeah, so there's no break. It's a fluent process, and I think that you more than us know what is time pressure and quality pressure in projects, and this is, I think, the topic or the method and the workflow to answer or to have answers, because then it makes engineering not only faster, but you save your quality. And just imagine how easy it is to maybe implement some changes in the project, because we all know these last-minute changes. Huh? Maybe
Absolutely.
You experienced it as well. Huh?
Yes, yes. And you don't start from scratch. If you have ePlan and you've created projects, go back through your projects, identify the standardized circuits, pull them out, put them in a library, connect that library to eBuild, and there you have it. Click on a button and generate all the projects that you want.
Great. And if we did our job and you say now, I want to step into this standardization, maybe tomorrow or better today, just visit eplan.com. As Sean mentioned, the solutions are there, and also prepared templates are there. So if you think about creating your own standard, your own library, have a look at eplan.com. You find the data there, you find the tools, And in addition, you find e-learnings about these topics. So you can even go more into depth and find out, okay, what is your right level to start and make your first steps in standardization. Okay, so this is one of our spotlight topics. There's more, maybe Sean, what is more?
Please join me to the other spotlight topics which I present, which is the pre-planning topic, how to become even more efficient by capturing data early on in the engineering process. And also, of course, my favorite topic is showcasing the new platform 2025. And the beta is already out, so please jump on the beta and use it.
Okay, and I just want to add another spotlight topic, that is standardization, so that somehow perfectly fits to our topic today. There we go into depths. What does it mean to standardize engineering? There is again, of course, we have some topics about the templates, about schematics and design rules. And then when we think more down the line, you can imagine that a high quality documentation is also very valuable for service and maintenance guys. So if all the information about the wiring, the components, the cabinet layout, etc. is there, it makes their job much easier. So then it's just to say thank you very much, Sean, for these insights.
Yes, thank you, Thomas, for moderating. It's been fun at work, and I enjoyed very much.
Yeah, and then let's say goodbye to the audience and see you soon in the next spotlight. Bye.
Goodbye, everyone.